a total charge q is distributed over two concentric hollow sphere of radii small r and capital R such that capital R is greater than small r, such that the surface charge densities are equal. Surface charge densities are equal. Then the potential at the common center is given epsilon 0 is permittivity of free space. So here we are having two concentric hollow sphere, one of radius capital R and other of radius small r, and let q is the total charge. Q represent what? The total charge distributed over the two concentric hollow sphere. And if I say Q1 is the amount of charge distributed over the outer hollow sphere of greater radii capital R, Q2 is the amount of charges distributed over the inner hollow sphere of small radius small r, then Q must be equal to Q1 plus Q2. Q must be equal to what? Q1 plus Q2. Now it was given that the surface charge density of two spheres are same, means sigma 1 is equal to sigma 2. But what is surface charge density? Sigma is nothing but surface charge density, sigma is nothing but charge upon area. Charge divided by what? Area. So surface charge density of outer sphere, it is equal to Q1. What is the charge given to the sphere of radii capital R? Q1 divided by what is the radii of sphere? It is a 4 pi capital R square, and that is equal to. Now surface charge density of radii sphere of smaller radii, Q2 represent the amount of charges given to the smaller sphere divided by what is the radii of smaller sphere? 4 pi into small r whole square into small r whole square. Now this is a 4 pi on both sides get cancelled. Therefore we have Q1 divided by capital R square is equal to Q2 divided by small r square. Q2 divided by small r square, which is equal to, now you can write it this equality as Q1 plus Q2 divided by R square plus small r square. R square plus small r square, but we know Q1 plus Q2 is equal to Q, total charge. So it is Q divided by capital R square plus small r square. Now from this we can find the expression for Q1 and Q2. See here, Q1 is equal to Q into R square divided by R square plus small r square, and Q2 is equal to Q into small r square divided by R square plus small r square. So we are having the expression for Q1 as well as Q2. Q1 as well as what? Q2. Now we want to find out what is the potential at the common center. Potential at the common center. So potential at common center of two concentric sphere. Potential at common center. Potential at common center of two concentric sphere. Of two concentric sphere. What is potential? Potential at common center of two concentric sphere is V equal to, say, V1 plus V2. What is V1? It is 1 upon 4 pi epsilon 0, means V1 is potential due to outer sphere into Q1 divided by, because that center is lying at a distance capital R from the surface of outer sphere. So it is Q1 divided by R plus V2 is potential due to what? Smaller sphere. So it is again 1 upon 4 pi epsilon 0. What is the charge distributed over smaller sphere? It is Q2. And what is the radii of smaller sphere? It is small r. It is what? Small r. So what we can take common? 1 upon 4 pi epsilon 0, that is taken as common, and in bracket it is Q1 divided by R plus small Q2 divided by small r. Now we can put the value of Q1 and Q2 here in this equation. So we will get net potential at common center is 1 upon 4 pi epsilon 0. Now in place of Q1, here R will be written as it is. In place of Q1, what I can write? Q into R square divided by, Q into R square divided by what? R square plus small r square. r square into small r square into this divided by r as it is, plus now q2 upon small r. What is the value of q2? It is q into r square divided by r square plus small r square into small r. So, one r will get cancelled, one r get cancelled, and we had the net potential at the common center as 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0. Now see here, what can be taken common from the numerator? Capital Q is taken common. So in bracket it is r plus small r divided by r square plus small r square plus small r square. So Q into r plus r upon r square plus small r square. So which option is correct? Look at this option. Q into capital R plus small r. Here option A, Q into r plus small r divided by 4 pi epsilon 0 into r square plus small r square, 4 pi epsilon 0 into r square plus small r square. So the correct option for this question is option A.